Assalamu alaikum viewers, my name is Varisha Kaval and my registration number is 16T86. Now we have a lecture 14 which is about signal analysis and sampling theorem. In signal analysis, let us consider the example as x of n is equal to 1, 0, 0, 0 and 0. Here we have the impulse train, which is actually delta of n, but it consists of only 5 digits. As we know that 5 is the odd number and we cannot divide into the some integer, that some finite integer, that value is not of some decimal value. So actually we take the value of n here as 8, because in impulse we can easily put zeros after this and before this, because we have the impulse train and it is only 1 at 0. So in this case, when we will find x of k using FFT, the same procedure is used. 1, 0, 0, 0, 0. Now it becomes n is equal to 8. In binary, it is written as 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. After bit reversal, it becomes same, and now we have the 2-point DFT. In 2-point DFT, we have the values 1, 1, 0, 0, 0, 0, 0, 0. In 4-point DFT, we have something like this. And the answer here is 1, 1, 1 for even and 0, 0, 0, 0 is for odd. Then we have the 8-point DFT. And it gives the values 1, 1, 1, 1, 1, 1, 1, 1. But when we shift it, as it is delta of n, when it is delta of n minus 1, it is actually equal to e raised to the power minus j pi 2n over capital N. And for delta of n minus 2, we have the values like 1 minus j 1. Next is the sampling theorem. What is sampling theorem? Sampling theorem is stated as that the sampling frequency must be greater than or equal to twice of the maximum frequency. This is the statement of sampling theorem. If some signal does not satisfy this condition, for example, if f of s is less than 2f of m, then the signals overlap each other. Just like here, the signal overlap because f of s is less than 2f of m. So this condition is, this overlapping is called aliasing. We solve this problem by using a low pass filter, but if we use the low pass filter here, then it when it applies, it not only filter the high frequency component, but it also copies the other component, as we see that two signals are overlapping. So the solution for this problem is increasing sampling frequency, decreases aliasing. Another thing that we can do to reduce aliasing is if we apply filter from ws minus wb to minus ws plus wb. So in this case there is a reduction in aliasing, but here we have another problem, that here we get a loss. Actually, in this case here we have ws minus wb, ws plus wb, ws, ws. So the best solution for this to reduce aliasing is band limitation. Band limitation or band cutting, actually it lies in the mid. We first low pass the filter, then the signal must be sampled and it will give a minimum loss, and it reduces the aliasing. So this is the most feasible solution to reduce aliasing. In this case we have the minimum loss, and after low pass filtering the signal can also be sampled. For example, if we have a signal x of c is equal to cos of omega t, and it is plotted like this, omega naught minus omega naught omega s omega s. Let omega s is greater than 2 omega naught. If the signal notch out, then we apply the low pass filter, and if ws is less than 2 omega naught, then we notch out this part, and the final signal we get is So this is all about signal analysis and sampling theorem. Thank you.